All right, folks. Good afternoon. Welcome to the session on blobs and tables. My name is Mallikarjun. I'm a program manager in Windows Server and Services organization. And
I'm Bekim Demireskil, so a program manager in the Windows Server division.
Yep. OK. So we will we'll start here, and I'll start off by presenting. Let's see. This kind of comes back to the same slide. All right. So I'll start off by presenting a little bit of context on the work here and why we are doing it. Let's go to that slide. How many of you had seen or heard about Microsoft Azure Stack coming into this session? Pretty much most of you. That's great. Have you been able to attend this session, the one about Azure Consistent Service Delivery? This is with Natalia and Bradley Bartz. OK, good. Some of you have. That's good. So this forms the context for the work here. We have a set of technologies in Azure Portal and Azure Resource Management Services and IaaS and PaaS services, all the content that you see on the right-hand side of your screen, right? Now, what we are doing is bringing that innovation all to on-prem. So Microsoft Azure Stack can be your local data center local for your hosted cloud or private cloud. You can have the same Azure-like resource management, portal, IaaS and PaaS services, and all the underlying technologies as well. And this all is built on what we call as the cloud-inspired infrastructure, meaning it's based on Windows Server, System Center, and all the technologies that you're very familiar with that you've been using in Windows Server 2012 and 2012 R2. That's one part of the context. The second part of the context that I just want to have folks keep in the back of their minds is about software-defined storage. Microsoft offers a choice to customers here. You could deploy storage in a variety of form factors with Windows Server and System Center Stack, starting with private cloud with traditional SAN and NAS storage to private cloud with Microsoft software-defined storage stack, which is sort of the second pillar from the left there, which is primarily where this talk is going to be focused on. But there are also some deployment configurations that support the first, as we will see later on in the slides. And hybrid cloud storage, Stored Simple. There are a couple of sessions on Stored Simple. In case you haven't checked them out, you should definitely check out those. That provides the hybrid storage solution for your data center, tiering to the cloud, tiering to Azure. And lastly, of course, you could use Azure itself, right? So there is a multiplicity of choices here, and we are going to focus on the second pillar from the left here for today's talk for the most part, and talk about what is it that we could do there. So we use the term Azure Consistent Storage to describe this concept, and you could. So what is Azure Consistent Storage? In a single slide summary of what it is, it provides a set of consistent services, storage services that are available in Azure for private clouds and hosted clouds. And when I say services, I mean three distinct things here. One is the blob service, the second is the table service, and the third one is the account management services. As you can see here, it's based on the scale-out file server and storage spaces technologies that we already have, and the high-speed SMB network fabric that we have. So that includes continuous availability, multi-channel, SMB multi-channel, RDMA support, and all that, right? And a set of Azure Consistent Storage services that are running as virtualized form factors, right? So they're all running in virtual machines, basically. Think of them that way. So this is the storage for Microsoft Azure Stack. This is the storage solution. In the previous versions, when we called it as, it's actually slightly different technology, but in Windows Azure Pack, if some of you are familiar with that, there was no storage as a formal first-class object. We are changing that with Microsoft Azure Stack, and storage is a complete first-class object with tenant and service provider experiences built in all the way through. And the other cool thing here is consistent tools and APIs. You could use the exact same PowerShell, same templates, same APIs, everything as you would in Azure with the Azure Consistent Storage as well. And PaaS and IaaS, those services would be offered on top of this platform. Going back to the very first context slide that I had shown earlier, we're really trying to provide the same set of services for on-prem. And we want to preserve the goodness and the performance of Hyper-V or SMB that we had already built in previous releases with this. So for the IaaS VM runtime, we would still use the highly optimized code paths that we already have. But everything would be consistent with respect to Azure and works like a charm. So I wanted to, first of all, introduce the multiple personas. This is the way we think of, and these form the distinct lenses for today's conversation. There are three distinct personas we think about. One is the storage developer, the person, of course, who writes to cloud storage APIs, blobs, tables, consumes all that good stuff, right? The other is the storage service provider who provides those services in a hosted cloud or a private cloud administrator. And the third facet here is the storage tenant administrator. This is really not the developer, but really the tenant who sets up the initial configuration, the namespaces, the accounts, resource groups, and we'll have a lot more detail coming up on each one of these three personas. But this is really the sort of rubric that we look at the entire solution through. We offered two distinct experiences here. One is PaaS with Azure Block Blobs and Tables, and then IaaS with Azure Page Blobs and under the covers internally based on SMB. Together, what that means is storage tenants run the same Azure cloud applications on-prem in that cloud because it's the same APIs and everything works without any changes. The second aspect here is from a developer perspective, as I briefly mentioned earlier, all the way down to storage client library APIs and PowerShell commandlets, and there is perfect consistency for block blobs, tables, and page blobs. It means I, as a developer, I could just code to the same APIs that I'm very familiar with. And the third is the rich service administrator experience, both portal-based as well as a new set of PowerShell commandlets. And that would be very powerful tools as well. Now, what do each one of these personas get? From a storage developer perspective, they develop using the same APIs, they publish using the same tooling that you already are familiar with, and maintains the code using the same Visual Studio, TFS, all the tool chain remains the same. Right? And from a storage service provider perspective, having this consistency makes them the preferred service provider because now the tenants have the agility, the mobility to move their applications from their private clouds to the hosted clouds to public cloud. So they become the preferred service providers with this technology. And they can leverage Azure as much as or as little as they like. For example, they can federate their on-prem on-prem Microsoft Azure Stack Gallery with that of Azure and have the applications published in Azure show up in their on-prem marketplace. And they can customize it to provide the necessary differentiation they might want against their competition as well as against Azure. It's up to them. And the tenant administrator gets to manage the onboarding, the initial, the infrastructure, let me put it that way, the virtual machines, storage accounts, resource groups, all the core underlying infrastructure resources are still managed by the tenant in a consistent way across Azure and on-prem or hosted cloud, it doesn't matter. And then he can choose really at the application deployment time which cloud he wants to go to. This cloud, that cloud doesn't really matter because the scripts, the existing IT processes, they would pretty much remain consistent because all the underlying IT professional tool chain is also the same thing. It works. And they can bring their own custom images, disks as well, and that works as well just fine. Now, there is one other subtlety that I just wanted to point out to folks before we dive deep into the rest of the presentation. There are actually two roles on the storage service provider side that we think about intentionally as different. And the one is the storage fabric administrator, who manages the traditional storage fabric lifecycle, meaning setting up file server clusters, storage pools, spaces, whatnot, right? All the what we today consider as storage fabric. And that is fine. And there is another role on the storage service provider persona side that we're introducing that we think as distinct. Okay, that is storage service provider, the person who manages all the storage cloud services, the Blobs service, table service, the storage account management services, the billing, usage reporting, all the cloud services as a distinct role. Now, that said, we realize that this is not a prescriptive guidance per se. We realize that in some cases, you may actually have both those roles combined into one person, and that's perfectly fine. But this forms a good view for you to think about as we go along. And let us start off with the storage developer, which is the developer persona that I called out earlier. Let me breeze through a couple of basic background concepts, and pardon me if you're already familiar with these, because really when you think about it from the developer side, we're not really bringing anything that's any new big hump here to climb here, right? There is no big learning curve required. So all the concepts in Azure, Azure Blobs, and tables, they basically work on-prem. And in terms of concepts, subscription is the billing relationship. That is that's what a tenant starts off with initially in Azure or in public cloud, on a managed cloud or private cloud. And then they create resource groups inside those subscriptions and then create storage account or accounts in those resource groups. And there could be other resources too. I'm a storage guy. I'm thinking only about storage for this talk, right? But there could be other resources like virtual machines, SQL databases, websites, you name it. There could be a variety of other resources in a resource group. And within a storage account, there could be containers with block blobs and page blobs, and there could also be tables as well, right? This is the sort of a very quick summary of the storage concepts. Now, I have a slide here that's really more intended as a reference material because in the interest of time, I'm not going to go through each one of these rows. There are a variety of good reasons on why developers should really care about object storage at all. Should they even worry about blobs and tables for on-prem application purposes, development purposes, right? So the bottom line here is probably the last row there. For high performance, low latency, local workloads, you probably want to prefer your traditional storage abstractions, block or file. And with object storage, it's great for workloads that require distributed access from HTTP-based web access and multi-tenancy as well, right? I mean, for those such applications, this is great. That's really the gist of it. Let's one other slide before we move off to the next persona. The Visual Studio tooling experience will be identical to that in Azure for Azure Storage. And Visual Studio will have the ability to publish to local endpoints, on-prem, blob storage endpoint, on-prem, table endpoints, etc. And that would be available when Microsoft Azure Stack previews later this year. Now let's switch to Fabric Administrator. This is a role in storage service provider side, just as a reminder. And the Fabric Administrator, when you think about it, he or she deploys and manages all the storage fabric infrastructure. That includes all the components up there. Using the tools up there, VMM, PowerShell, DSC, all the technologies that they're already very familiar with. We are not really bringing any new fabric administration tools as part of this project. This is really expecting the existing tools would work great, and VMM would provide the necessary complete management capabilities for all the features that we are shipping in Windows Server 2016 TP2 as well. So that will continue to be the preferred fabric management technology for that. And then the fabric administrator works with the storage service administrator for capacity, resource provisioning. What is it that my storage cloud services guy want from me in order that he can go and build the storage cloud services on my fabric resources, right? That's really the thinking that goes on here. And Azure Consistent Storage is software-defined storage, but it also means that all the fabric resources that we have, they're still there, right? They're still required to be provisioned. They're still required to be managed at the fabric level. And that's really what the fabric administrator is doing. All the items require pools, spaces, ReFS, and cluster shared volume, scalar file servers. All those concepts are still there. They need to be tended to, and they need to be provisioned, configured, monitored, all that. And the cool thing here is this, right? I mean, Fabric Administrator with that one single cloud, the storage fabric, he or she can actually provide two different kinds of services. One is the more traditional non-object storage, files and block kind of solutions. The other is really you provide provisioning blobs and tables off of the exact same storage fabric. We are not really, this is not really a rip and replace kind of a solution, right? We have one storage fabric and we will build one private cloud storage stack, and you can offer blobs and tables on it, or you can continue to offer the more traditional file and block interfaces on top of the same fabric. Now, deploying. How do we deploy Azure Consistent Storage? There are multiple deployment options, as it turns out. One is the recommendation that we have today. You could use the existing technologies, either Storage Spaces Direct with our software-defined storage, or shared JBOD-based software-defined storage solutions. How many of you have heard about Storage Spaces Direct, by the way? Has anyone? Okay, several of you. That's great, yeah. I think Klaus Jorgensen, who is one of my colleagues, has a session on it tomorrow, if I remember right. You should definitely check it out. There was a very brief demo during the storage overview session yesterday, and there will be a much more deeper talk tomorrow as well. So you can continue to use the Spaces solutions. That's the bottom line, right? Or you could also have object storage, blobs, and tables deployed on top of potentially a partner solution based on SAN storage, right? And as long as the SAN storage has a scale-out file server as a front end, this whole stack works like a charm. We don't really care at some point beyond SYFS, right? Whether it's SAN backend or it's Spaces backend, when you think about it. Or you could actually have compute and storage together in what we call as a hyper-converged deployment configuration as well, based on Storage Spaces Direct. That's also a possibility. So there are multiple deployment options to choose from. So with that, let's just turn our attention to Storage Service Administrator. Storage Service Administrator is that bottom guy, again, for reference and legend and where we are in our persona walkthrough. And the Service Administrator works with the Fabric Administrator for initial planning and the initial capacity resource planning. And the Fabric Administrator just uses existing tools, as we have discussed before. And the important thing the Storage Service Administrator does really is deploying and managing the cloud services, initial rolling out of the blob service and table service, account services, and really trying to keep track of their end-to-end lifecycle management, monitoring it, and producing usage reports, and diagnosing, debugging, everything, right? That's the entire lifecycle. And the other most important thing that a Storage Service Administrator does is create storage offers for tenants to consume. These are really the package of cloud services for a tenant to go obtain, right? That's really what the tenant can get their hands on. So we'll see a demo of that in just a couple of minutes. So the other important thing here is this is really the storage for Microsoft Azure Stack, right? The Azure Consistent Storage Cloud Service, you download it and deploy on top of the Microsoft Azure Stack platform. That's really the approach here. There was actually, I think maybe just finished, Robert Reynolds had a discussion, a session on Azure Stack Roadmap. I don't know if any of you had a chance to catch it, but that would be a good one to refer to understand how we will continue to support Windows Azure Pack for multiple releases, as well as start delivering and supporting Microsoft Azure Stack in parallel. So we will actually be supporting both for several years here. A couple of concepts that I just wanted to introduce here. One is regions. Region is a collection of resources, and maybe in one geography, maybe in one site. They're all being managed together, and that's what Microsoft Azure Stack calls as a region. So you go create the necessary regions you want, and there is one storage resource provider, which is the component we use for integrating the storage cloud service management into Microsoft Azure Stack framework, right? There's one such storage resource provider per region, and basically off you go. And you can create and add storage fabric resources into what we call as a farm. Farm is, think of it as a collection of all the storage resources. There may be multiple. There may be multiple scale-out file server clusters, file shares, and all that, right? So all those items together we refer to as a farm. So basically, a storage resource provider manages a storage farm in a region. That's really the model to think about. Create plans and offers, which we have discussed. So when you think about it, there are a bunch of fabric resources, virtual machines that together constitute or together feed into standing up Azure Consistent Storage Services. Virtual machines, file shares, replication, configuration, whatever you choose to build. Scale-out file server clusters, networking, load balancers. We'll see where load balancer comes into picture just in a minute. And the fabric administrator, the storage service administrator is taking all these fabric resources and composing them into a bunch of cloud services that tenants can consume. We start off by building Azure Service Fabric clusters. Has any of you gone to the Azure Service Fabric session yesterday? Anyone? Okay. So there are a couple of you actually. That's good. So Azure Service Fabric, think of it as a technology for developers to build hyperscale microservices in Azure. That's what Azure uses today for all the hyperscale services like Azure SQL, DocDB, and Bing Cortana. All those run on Azure Service Fabric technology. And what we're doing is we're taking that same technology and we are bringing them to on-prem for private cloud or hosted cloud, right? So we, as an Azure Consistent Storage team, we use the exact same technology. We build our clusters based on Azure Service Fabric. We build other front-end table virtualized services. We build blob service on scale-out file server, then build management, and then integrate it all into Azure Stack. Right? Then you basically have storage cloud services in production. So Azure Consistent Storage is scale out in multiple dimensions. That's the very cool thing about this. Let's start off with the same basic diagram. There are multiple front ends, front-ended by a software load balancer. It could be hardware, that's fine. You need a load balancer in order to distribute the incoming traffic amongst the multiple front ends. Now, scale out is possible here at front-end level. You could add or remove front-end nodes dynamically when the farm is up and running, right? That's one dimension. You could have, of course, add scale-out file server nodes to remove them as, again, during live uptime. That's another. And of course, there is a blob backend service that runs on every cluster node, and that linearly scales as well. Every time you add a scale-out file server node, you basically have a blob service that goes with it. And it's also possible to add additional clusters altogether for resiliency reasons, for whatever reasons, if you choose to add capacity reasons, if you add additional clusters, that just works fine. So let's start with the basic diagram again and think about regions, right? I very briefly mentioned the concept of regions earlier. Within that, let's talk about a couple of things that I have added. The management stack components that I just added in this diagram, if you have noticed. SRP, which is the storage resource provider, manages the storage account lifecycle in this region. And then we have some object to share mapping services, health, metric service, all those other what we call as utility services also running on that, right? There is also, could be other cloud services, compute, SQL, websites, database, right? So all those services are also there within the same region. And there would be one resource provider per region, per cloud service. That's the important thing to remember. Now, the storage application client in a multi-tenant way is accessing blobs and tables there on the blue box, right? The blue client. Now, I also have an orange client there. The orange client is the management client, meaning is doing tenant administration like creating accounts, creating usage reports or whatnot, right? Those are also multi-tenant. So basically, we have a multi-tenant data path, multi-tenant management path, all running on the storage fabric that you already are very familiar with. Now let's think about the storage service administration side. Let's again start with the same basic diagram. I just threw in storage spaces direct into this just to make the point that we're really building on software-defined storage foundation. And this is how they slot into the larger Azure consistent storage framework, right? This is a new technology that we have just introduced. Like I said, Klaus has a talk on it tomorrow. You should definitely check it out. There's a session pointer up there. SRP, as it turns out, is not only providing multi-tenant management services, but it's also providing storage administration, service administration capabilities through the same resource provider. So all the cloud storage service administration is done through, of course, another client here. And that's all portal-based, completely modern experience, along with PowerShell commandlets. And that's all, of course, you go to the same portal, as I will show just in a minute. You go to the same portal, depending on your privileges, you either get to see the storage service provider portion or not. Okay, so very quickly, what do we mean by offering storage as a service? Well, you start off with what we call as a plan, meaning these are the services I want to compose together. Here are the quota limits for each service, right? You combine them into a plan. And then you decide what is the region that you want to really offer them in. For example, for today's demo purpose, let's say Chicago region. And include storage as a service and set the appropriate quota limits that you want your tenants to consume up to in that, using that plan. Choose other services and put quota limits on those as well. And then define them all together as an offer and publish that offer, make it a public offer, and now your tenants are ready to consume out of that offer. I'll show this in 1 second to you guys. So just to summarize, right, the storage service administrator has multiple tools here to choose from. One is the REST APIs. We will have a comprehensive set of REST APIs for service administrators at the preview time. And we will have PowerShell commandlets, so you don't even have to worry about REST APIs at all. You can work with PowerShell. And there would be other deployment tools and other things that you need to initially bootstrap the service even before you have PowerShell tooling, etc., at runtime. And modern UI, the web-based portal experience that I just mentioned. So with that, let us see if my computer is still awake. I wanted to show a quick demo of, let me switch here. Okay, there you go. I hope I didn't have the model too long. Anyway, I just wanted to start off with these two screens here, split screen. You can see here, the one on the left here, this is the tenant. We'll come back to that in a minute. Let's focus on the one on the right, which is the storage service administrator interface. And as you can see here, the provider set of capabilities are only available from here. They're not here, right? So this is really, as a storage service administrator, this is really my starting point to start composing the things I want. Let me make it actually big screen here. Okay. So as you can see here, there are, for the purpose of this demo, let's focus on two regions here. I have a Chicago region and a Paris region configured in this cloud. And as you can see here, I have a storage resource provider for the Chicago region and one for the Paris region. Let me just click on storage Chicago region. So as a storage service administrator, I'm basically looking at the all-up view of the storage services that are running in the Chicago region, right? The API request, it shows some nice visualization of how many management requests had flown through that SRP instance in that region. And it also gives a nice topological view at the bottom. It shows how many table servers, table masters, the front-end nodes, the back-end blob services, how many are running all up, and what is their health, et cetera, right? Some of these things are still coming together. Remember, we still haven't entered preview. So I would love to get your guys' feedback on, hey, why isn't it there? Why is it not there? That kind of feedback is very welcome. But think of it as the sort of all-up summary of all the storage cloud services running in the Chicago region for the purpose of this demo. So let me close that view, if I can, and go back to plans. I just wanted to very quickly show the feature of creating a new plan. Let's create a plan. All the steps that I visually showed as animation in PowerPoint, we might as well see it all working. So I picked a name, and I'm picking a resource group for the plan itself. We can safely ignore that. That's an administrator resource group. And this is the interesting part. There are multiple set of services to choose from as part of this plan, and SQL, subscriptions, all that. So again, I'm going to focus on storage and say select. Once I select storage, the portal tells me that, hey, you have to configure a couple of things here for your storage service. I'll choose a region, okay? I'll offer it, sorry, I forgot to configure this piece. That's why I'm coming back to this. So I'll offer it in Chicago region, and I have 520. Well, if I'm in a generous mode, I might add one more zero here, right? So basically, I'm setting some quotas on that specific storage services that the tenant could consume. And I hit OK. And if I could hit OK, well, OK. And SRP demo plan. So what I have, and it shows as success here, and the SRP demo plan here shows up as well. So what I've just done is I've defined a new plan that offers storage services to my tenants. And I've set some quota limits on it, and the plan is out there. Now, the next thing I need to do before my tenants can get a hold of it is defining an offer. I'm going to call my SRP demo, let's say offer. And this is a resource group for the offer itself. That's fine. And the interesting thing is here, this one, right, the plan. And the plan that we just created, the SRP demo plan, shows up here as an offer to be packaged up into this, as a plan to be packaged up into this offer. So I'm going to select that and say select. Add-on plans is the similar thing. They're the optional services that a tenant could obtain or purchase, but we don't need to do any add-on plan configuration for the simplest of the offer that we're trying to build. Okay, that succeeds as well. And the SRP demo offer shows up here as well. So to summarize, right, so what we have just done is we started off with a clean slate. We have defined a new plan, set quotas on it. We packaged it up as an offer because we took that plan as a base plan into the offer and published that. Oh, one other thing before I forget. Right now it shows up as private. So in order for my tenants to actually consume it, I need to set it to be a public offer. So that way, when my tenants come here, they can actually see that there is an offer that they can consume. Okay, So that's basically it, folks. What I have done here is, like I said, I published my offer, and it's available for my tenants to consume. We'll come back and pick up this for my tenant experience back on the demo. Once we cover the tenant provider, tenant administrator experience here, we can go from there. All right. Okay. So tenant administrator is this other persona that we have earlier very briefly discussed. Let's double click on what a tenant administrator really does in the larger scheme of things here. Tenant administrator creates subscriptions based on available offers. Well, so we have just published an offer. We'll go back to that in a minute. Or, of course, you can choose to use an existing subscription. Creates and manages resource groups and storage accounts, and manages security for the account overall, rotating keys and allowing access to others through tokens, etc. Right? Now, storage account types. This is Azure terminology, by the way. A bunch of things that we're doing here. Right? This is all consistent with what Azure already provides in Azure. There's two kinds of accounts that we will support. LRS, the locally replicated storage, which is resilient to 2 data copy failures, meaning it could be triple replicated or maybe high performance dual parity. Basically, it's resilient to 2 failures. Standard GRS, geo-replicated storage. And in the way that we will provide in the on-prem solution is for the LRS, we will use the Spaces technology to do the local replication under the covers. For GRS, we will rely on the new technology called Storage Replica. There's actually a session up there. Ned is a fantastic speaker. Ned is a colleague of mine, and Ned has a session on Storage Replica tomorrow. So you should definitely check it out. It would be a fun session to watch. The mechanics, I think we kind of touched on this, right? They are the roles and responsibilities. Fabric administrator deals with Fabric. Service administrator deals with offers and plans, and the tenant really consumes those at the end of the day. So let's think about what a tenant really sees from his or her perspective. Well, tenant sees a virtualized namespace. The tenant starts off with all the tenant sees is an account namespace. That is the sort of root namespace for all the objects in the account, right? When he accesses a blob, let's say B1 there, right? That magically gets routed through software load balancer, some front end, and gets to a specific blob service instance running on a specific scale-out file server cluster node, right? Obviously, tenant doesn't care where it goes. Now, from a service administrator perspective, service administrator has added another cluster because maybe he wants resiliency reasons. He wants it to be a different cluster. Now, a couple of things to notice here, right? The account namespace is automatically virtualized across the available capacities. Storage administrator could add new shares, new clusters, all the while the tenant is up and running. There's no tenant downtime, and tenant, of course, from his perspective, the next time tenant creates a new object, and table this time say, that's automatically getting routed to a share on a different cluster altogether, right? And of course, tenants simply do not care. They just are continuing to use their same HTTP:/my account namespace for all their object accesses. And one of those objects may be coming from this cluster, another one of those objects could be coming from that cluster, right? And there's no URL changes either from a tenant perspective. Let's see, am I clicking the right one? Yep, okay. So let's very quickly, we will see this in action in 1 second, so I don't want to spend too much time on this slide. Basically, starting with an offer, a tenant creates a subscription and goes from there, from creating blobs and tables in that namespace. Similar to the service provider, a tenant administrator also has a variety of tools here. And the most important thing, folks, to remember here is they're all Azure consistent. They're the same PowerShell commandlers, same REST APIs. and the same tenant web UI experience as well, the same portal experience as in Azure. We're bringing it for on-prem usage. With that, let's turn our attention back to demo. I wanted to switch to my demo computer here, and we can see how the tenant can actually consume the offer that was previously published by the storage service administrator. As we saw here, right, this is the tenant login that I have on the screen to the left, and there is no provider capabilities here. It's all role-based access control, and so if you're not a service administrator, you don't really get to see any of the storage service administration capabilities. Now, let us add a new subscription. Hopefully my token didn't. Okay, good. So when I add a new subscription, right, what I'm really doing is, we can maximize it here. Okay. I'm starting with the list of offers that my administrator had published. And the SRP demo offer that we had published previously as part of the storage service administrator role, of course, I'm wearing both hats for this demo, but when the administrator publishes it, the tenant sees it here, right? So I'm selecting it and saying, okay, that's fine. That's really what I want. And SRP demo offer is selected. Now I will say SRP demo, I don't know, subscription, and hit OK. So, and the request succeeds. So basically what I have done is I have created a new subscription that forms my relationship with my service provider. I can create all my resource groups and accounts and everything in that. Is it okay to hold the questions till then? Oh, yeah, I'll be happy to stick around as long as you want, and we can continue. Okay, the other thing that I wanted to show is, let's go to the subscription. We can browse through the subscription here. And this is the same tenant user experience that we have in Microsoft Azure. You can browse through the subscriptions, and the demo sub is here. That's available. Now, I also wanted to show a little bit of PowerShell, because a lot of this can be done using PowerShell. Let's start with a clean slate. So what I have done in this PowerShell session is I have sort of pre-configured some of the environment here. Basically, I added my Azure account. It is the same add Azure account that you use in Azure. You also use here. We'll start with get. I think I should have a get Azure subscription here with the subscription name, subscription ID, I believe. So what I'm really trying to do is I'm trying to extract the list of subscriptions that I have created. The SRP demo sub that we just created using the portal shows up here, right? It has every ID shows up with the GUI, the global unique identifier, and you can start working with those. For the purpose of this demo, for easy copy pasting of all this, I already have some of this here. So I'm going to use with one of the existing subscriptions. That's okay. So we can run through this much faster. So I'm basically selecting a subscription that I have, and I'm also going to use an existing resource group that I already have pre-created, again, to speed up the demo here. So I will select that, and what I have done in the first step here is, did I not type in something? So what I have done is research group name. So So, well, what I'm trying to do anyway, as you can see here, I'm starting with a, let's actually see if the resource group exists in the portal. Yeah, I know. I'm just, is this my, yeah, okay. So when I go to my resource groups, it tells me that there is an existing SRP Demo 3 resource group that exists. So that's basically what I'm trying to use. I'm just double checking that it is there. So other than that, I'm not, hang on. Okay, this may be in the other mode. So let me just do a switch if I apologize here. Let's go to the Azure Resource Manager mode and do a, okay, that's better. So, so there are two modes that the commandlets operate in. One is the data path mode, and there's a, which is where I was, as it turns out. And this mode is really about using the new Azure Resource Manager compatible PowerShell commandlets. So we can double check. So that's a quick return. So let's actually double check that it was created. Okay, we do that. Okay, that shows up nicely. So what it's showing is I've just created a locally replicated storage account, LRS, right? And it is available locally on the Chicago region here, right? That's my primary location, and everything looks to be just fine. Now let's stop here for the. Actually, let me, before we switch back to the slides, I just wanted to show. Let's make sure that it actually shows up here. Okay. Okay. So this is the new account. If you had noticed, right, previously there was nothing in the resource group. We just created a storage account and slotted that into the resource group. It shows up nicely here. So everything works great. So now at this point, right, this is what typically a tenant administrator is doing: creating a subscription, creating a resource group, creating a storage account, and setting up the basic namespace for the development teams or for my application teams to go work with. So let's turn our attention back to the slides, and we can go back to how this is actually really consumed by via blobs and tables and containers and all that. Okay. Now, very quickly, let's do a very quick deep dive into blobs. I'll still stay at a fairly high level. Azure blobs are highly scalable and durable storage clients, storage objects, and you can store files as blobs and associate all the metadata, custom metadata that you want to them. And the API capabilities of Azure blobs is extremely rich. There's a whole ton of cool things you can do with Azure blobs. I'm just highlighting 4 different categories of things you could do. You could upload and download blobs with strong consistency, basically meaning that you wrote something, you got an accept back. When you read it, you're guaranteed to get back the same thing. They're strongly consistent. You could use a variety of concurrency schemes, actually: optimistic, pessimistic, last storage, writer wins, anything. All those things work. The nice thing is optimistic concurrency, which actually scales much better. We do support that with automatic e-tags and conditional headers, etc. So that all works great. Let's see. Yep. Okay. And snapshotting, blobs, creating backups, all that works fine. And least blob which is actually the sort of pessimistic concurrency model, where you actually take a lock because you kind of suspect there may be others writing onto it or you changing it, right? That works great as well. And range requests work fine. They resume semantics for efficient streaming and all that. So the net summary of it is these are Azure Blob functional capabilities, and they work just fine on-prem with Azure consistent storage as well. That's really the takeaway I want you guys to keep in mind. And the blob types, again, Azure supports two different kinds of blobs, block blobs and page blobs for two distinct purposes. And with Azure consistent storage, we deliver identical semantics. You could use the same thing for similar purposes, for PaaS and IaaS respectively in this case. Let's do one more level of deeper look before we go back to the demo. Blob persistence design. I've been talking about this blob backend in all the preceding slides without really telling what it really does. So let's talk a little bit about that. Blob metadata, let's first of all start with that. That's part of this, all double-clicking on the blob backend here, right? The blob metadata is in a metadata store that is really scoped to a large number of containers on that volume. There's a metadata store that corresponds to basically all the containers and each blob within each container on that volume, right? And the blob data itself, we talked about metadata, how about data? Data all resides on ReFS volumes. And the persistence approach, how we store a blob, depends on what type of blob it is. For example, with page blob, we store it directly in a ReFS file. And that's because the file-based semantics, they deliver efficient access to internal page blobs within the private cloud. When the VMs are up and running, they're consuming page blobs. If we keep it as intact as a ReFS file, we can deliver efficient SMB semantics, SMB RDMA, continuous availability, all those cool capabilities. So you actually see it on the file system as a file. Now, with block blobs, the story is slightly different. We take a block blob and we use an existing technology called chunk store that we already ship in Windows Server 2012 R2 and 2012. And we repurposed that as the underlying technology for block blobs, meaning each one of the blocks in a block blob maps to a chunk in our design. And it actually creates a distributed, a block blob is basically distributed in a chunk store, and a stream map keeps track of all the blob blocks that constitute that block blob. With that, I think, yeah, okay, let me just show a quick demo of the blob storage consumption itself. Then I will turn the floor to Beckham, who is patiently waiting so he can double-click on the tables. Oh, sorry, I'm not showing. Okay, so this is where we left off for the tenant administrator. Let's go to actually, let's start with PowerShell. So this is a new account that the tenant administrator had created for me. I'm a developer. I'm starting to work with my existing storage account, right? That's SRP Demo 3 in this case. Now, what I want to do is, the first thing I want to understand is, hey, so let's clear that away. So that's all a different role. I'm wearing a different hat for this demo. So let's start with a clean slate. As a developer, I will want to know what are my storage account keys for this specific account that I've been provisioned by my tenant administrator. So just like in Azure, for every storage account, we have 2 storage account keys, and they are used for authentication purposes. At this point, I'll say, okay, I have the keys. Now let me try to create a context token based on those keys. The first key I have here is this guy. Oops, sorry. I'm not doing. All right. Okay. So I copy-pasted that key. So what I'm really trying to do, let's see if there's anything else at the end. Yep, there is. So what I'm trying to do is, hey, I have a Chicago region, and I'm really trying to consume my storage account in that Chicago region. I'm creating a context token so I can refer to all the subsequent operations based on that context token. Right? So that goes ahead and creates a context token. Now, the rest of it is, again, this stuff is identical to as in Azure, folks. This is not something new for on-prem that we are creating here. It's the exact same way you would consume the command that's in Azure. What I'm doing is I'm just creating a new storage container, Chicago demo container, using that context token that I've just created in the preceding step. Maybe it's too long, huh? Oh, okay. I should have checked, but let's just say my demo container and see if that works. Okay, that works. So at this blob endpoint, right, the storage demo 3, which is the new storage account that I've created, and at that Chicago region of my domain, I've just created a my demo container container. And when I say permission container here, what I'm basically saying is, hey, I'm allowing anonymous access to that. Now let's try to do one more thing here. I want to actually show another tool. This is Azure Storage Explorer. I don't know, how many of you have already used this tool? Okay, a few of you. Yeah, this is the same tool. You know this. I mean, this is the same tool that that's available on Codeplex. We just downloaded it as a binary on this machine. I just installed it. I didn't change a single line of code. It is the exact same code that's running in, that works with Azure. I'm just using the same binary, right? So let me try to do one other thing. So I just want to show the complete experience here. Okay, sorry, there's a little bit of a lag there with all the VPNs, etc. that I'm using. All right, storage endpoints domain, I will say blob dot, I think that's what it was, right? Yeah, would say actually Chicago. Chicago.2015demos.com. The test access, the account access is successful. I'll save it away. So hopefully it takes a couple of seconds sometimes, but it comes up, trust me. What it does is it's basically, I have a file explorer kind of tool looking into my storage account here, and that should pick up the same container that I've already created through my PowerShell, right? Once it picks that up, whenever it does, it's still loading. Okay, cool. So my demo container came up, right? Now I can take an existing file. For example, I have a couple of files here. I have a photo of the synchronized fountains downstairs in the same conference. So let me try to upload that as a blob and see if that actually works. Ignite sync fountains. Okay, there you go. So now it's actually uploaded into my blob store as a blob, right? If I double click on it, it shows me the full metadata. It shows it as a block blob, and it shows some auto-generated metadata for that block blob, last modified time, and all that good stuff. It also shows me the URI at which the block is really available. The block blob is available for access. And because I have defined that container as a container that allows anonymous access, if you guys remember, I can basically use that URI just via a browser. Because remember, it's HTTP accessible. The same blob now shows up as a block blob through my browser, right? So what have I done here? Right? We started off with PowerShell for this last section of the demo. We took a storage account, we created a container in it through PowerShell, then we went to a third tool, Azure Storage Explorer. We uploaded a blob, and it's an anonymous blob that I can access without any authentication, so I just went ahead and accessed it using my, my browser, standard internet browser. Now, so we have looked at a couple of things in summary. Actually, Beckham, maybe you should be coming up. Yeah, I think I'm done here. So just while Beckham is setting up, right? So we have shown a couple of different tools here. We have started off with the portal, and then we looked at PowerShell. We looked at Azure Storage Explorer, and they all work great. And we will have other administration tools as well coming up for the real, by the time we will review it later this year. Beckham, you want to take it away? You good?
Yeah.
Thank you.
Okay, so let's do a quick tour of tables. Before I start on that, I have questions for the audience. So how many of you are developers developing code against Azure or locally? Okay, we have just a couple. I'm assuming the rest of you guys are some sort of IT service administrators, either in IT, in an enterprise or a service provider. Okay, good. So let's just take a quick look at what tables really are. So this is more developer-oriented. This is really how developers are looking at our table service in Azure. It's a key-value store, so it's a NoSQL key-value store. You've probably heard about this from your developers, very popular recently. And what that means is you basically, as a developer in a storage account, you can create 1, 2, 100, 1,000,000 tables if you want. And each of the tables is very simple. This is not like a SQL table that has, you define the columns. Each column must have a data type, constraints, yada, yada, yada. You basically just define the table, and in the table you start inserting these objects called entities. And each entity can have a variable number of properties. As you can see here, I have 4 entities, and each one of them have a different set of properties. The only really core properties, key properties are the first two, the green one and the orange one. The green one is the partition key, and the orange one is the row key. They really are the only things that uniquely identify the entity. And the partition key is something that the developers used as a strategy to partition all their data so that we can efficiently manage that on their behalf. They can scale it from a few rows that just manage a little bit of the settings of an application to millions or hundreds of millions of rows that manage all your users' accounts, or all your user status, for example, in your application. So this basically, this flexible schema enables for rapid development. A developer that needs to develop an application doesn't really need to go and think very hard about how they will design the database schema upfront. They go and start developing the application. A lot of these very simple cases turn out into large applications. If this turns into something that requires a more structured and more organized database, then people can go and migrate to something like a relational database. There's a lot of usage examples around this, and people use this for shopping carts, for address books, for keeping device information, status of servers. You can, we have some services that I've been working on where we work on 100 or 200 VMs, and we keep the status of each of the servers updated in a table. We have large operations inside Microsoft that keep actually all their events and metrics from their whole system, from their whole service in tables. And then systems that go over the tables, query the data, and raise alerts. Inside Microsoft, we have MSN using this. We have Xbox using this for a lot of their internal stuff. We have Bing and some of the other services. And there's literally thousands of customers that use tables. We have several million tables stored in Azure. Actually, nobody really knows what's the number, but it's in the millions. So that's kind of the developer perspective on this. Now, I don't want to make this look like the solution for everything in the world. It's really a part of a larger landscape of database technology. If some of you have been at the talk, there's this guy called David Chappell. He gives a very good talk of all the NoSQL technologies and what we offer in Azure. And this is kind of a snapshot I borrowed from him. There are a number of these NoSQL technologies, and then they play together with the more traditional SQL technologies. They're divided here into more operational, transactional systems and more analytical systems. I'm sure as developers, you have used at least one of this. You're constantly using at least one of this, if not more of this. If you're providing services, infrastructure services to developers, I'm pretty sure they're running several of these today. I'm pretty sure some of your developers are running things like Cassandra or MongoDB. And if you're working in Azure, you're probably working with any of the, at least one, if not more, if not all of the ones that are highlighted here in yellow. So Microsoft now in Azure, we basically have technologies that cover this full spectrum as a service. Now, if you think about how your service provider, either in an enterprise or as a hoster, you're basically just providing infrastructure. If you think about how people use these database technologies today, well, a tenant, let's say a developer is tenant A. They will develop their application. They will put the application code in a VM, and then they have to get a bunch of VMs and deploy the database technology there. So if they're deploying something like Cassandra or MongoDB, you need a few, at least 3 VMs or not more. And each of the VMs has their own role. The developer really has to think about how they're going to deploy this, make sure that it has high availability, how they're going to back it up. There's a number of considerations that they have. It's essentially a DevOps problem today. And each developer, each tenant repeats the same problem. So if you're in an IT organization, that's not really necessarily the most efficient use of resources. Each of your development teams is repeating, potentially deploying the same product, the same database technology multiple times. So the DevOps cycles are really spent on maintaining these individual database deployments. And then, as part of their work, they actually have to go figure out how to ensure high availability, disaster recovery, solve all of these problems. Now, in Azure, the services that I described are very popular. Azure Storage Table Service is very popular because it just relieves the developer of having to think about how they're going to deploy all these database technologies. If they want to use something as simple as table service, all they need to do is deploy their application and then go to the Azure Table Service and ask for the Azure Table Service to create a bunch of tables. It's in the Azure Storage Table Service that we take care of, making sure we have three copies of the data, so we never lose any of the user data. We give you geo-replication, so geographical distribution of data, and so on and so on. And what we want to do on-premise in your private cloud or in your hosted cloud is basically replicate those same capabilities. So you, as a service provider, can offer these higher-level services to your developers, not just infrastructure, but these higher-level developers services for your developers. That basically frees up their developers to really think about the core parts of their application, the code, the tables, databases, queries, instead of thinking about how to actually deploy all these database technologies in a bunch of VMs. That, of course, as a service provider, that elevates you. So you're now offering some higher-level services. You can charge more for them. And a lot of this very important stuff that people don't really think about much up front is already baked in. You have the high availability, disaster recovery, workload management. All of that is done by the person who is operating the service and relieves the developer. There's another important point that's not listed here is with the previous model, a lot of this data is actually still locked in these application silos. So each development team is kind of managing the data. Your databases, which could be some important data, is sitting in some VM. This actually makes this, especially for an enterprise, this makes all the data storage transparent. You can actually go and enumerate all the tables, all the accounts, and all the tables and see where this data is. So if you're working on data management, that is becoming more and more important. I'm going to switch now and go into just a little demo. So I have here a very simple example of an application that we just wrote for this demo. It's a very simple presence application, okay? So I have 2 users here logged in. One is Bob and one is Alice. And what the application does, it goes and talks to a single table in Azure. So this is an application written by an intern. It just goes against Azure. They didn't know anything about our on-premise offering. They wrote it for Azure. You can think of it as a kind of like a dev test scenario where they go and develop the application in Azure. And what it does, it does 2 things. Each 10 seconds, it goes and reads a table in Azure in which all the users are stored and their current status. It's a very simple table. And then I can go and change the status. So if I'm Bob, I can go and change the status from available to busy. or to offline. And about 10 seconds later, there we go, Alice can now see that Blobs is offline. So you can imagine, 2 users, 10 users, 100 users, 1 million users going and using the same table and getting pretty much the same level of performance. These are the type of applications. It's a very simplified type of application, but it's a good example of the type of applications that developers build on Azure tables. There's a lot more complex applications that use multiple tables, copy data between them, and so on. But I just don't have time to show all of that to you guys. Now, we took the same application, and without changing any code, all I do here is change configuration. So I already have a storage account that I created in the Azure Stack on-premise deployment. And all I'm going to do here is run the same application. The exact same application, no code changes. If you look in the source code of the application, there's no if-def, or if storage is Azure, then use this kind of APIs, or if this is on-premise, use this other kind of APIs. It's the same application. The only thing that changes is these 2 endpoint settings and account settings. So all I'm saying is, instead of going to Azure and use an Azure endpoint, go to my local Azure stack, use a local endpoint, use the storage account I created for you, and the application just works. So you can think of this scenario as the developer starting working on the application in Azure, and at some point, the organization decided they will deploy this on-prem in the private cloud. The developer, the only thing they need to do is reconfigure the endpoints, application works. At some point, let's say you have a very large event, you need millions of users, you cannot handle this on the local on-prem infrastructure. Again, switch the endpoints, point it to Azure. You can handle that particular burst needed in Azure, and then come back to on-premise again. Okay, so that's just a simple illustration of the capabilities of tables, and what we are offering on-premise is fully compatible, fully consistent with what we have in Azure. Now, for the service admins, so you don't have to be necessarily a C# programmer, an application programmer. There's actually a very interesting way of using tables, even from PowerShell. And I'll show you an example here very quickly. Let's say you want to do the following scenario. You want to collect events from a bunch of machines, and you want to analyze them. You want to do this periodically, maybe every 15 minutes. In order to do this, you need to collect the data someplace. Well, tables is simple enough, so you already have it in your data center. You already deployed this. Now you can start using it to deploy data. It's not like a database. You don't have to deploy a SQL server, create a database, create tables. You can just write some simple PowerShell scripts that goes and takes the data from the event login windows and dumps it into this table. So here's the script. This is the PowerShell script. So this is a set of parameters. It basically just sets the local endpoint, the local Azure Stack table endpoint. There is a very simple piece of code that sets up the connection string. So this just connects you to this endpoint and sets up the table. This is the table that we're going to use. There's already PowerShell commandlets that are provided in the Azure SDK that we are using here directly. And then we have another function here that basically takes an event log entry from one of the standard PowerShell functions that returns the event log, and it creates an entity. So this entity is basically an object that you create from the table API SDK APIs. You create it, you assign a set of properties to it. And then the last thing that we do is we go in and execute an operation against the table, which is doing an insert or replace. So basically, it's just taking this record that we created out of the event log and dump it, create an eventity, and go and insert it into a table. So the way I would run this is So we can get the event log with something like this. Oops, I made a mistake there. So I'm just getting here the latest 10 entries in the event log. Okay. This is a standard commandlet for getting event log entries. And all I'm going to do now is pipe that into this PowerShell script that I just created, which I call export event log. Okay, so we get the entries, they get pipe typed into this code we just wrote, and that gets sent into the table. If we go back into the Storage Explorer, I'll go into my demo account. All that went into this logs table. You can see there all the entries are in there. I'll just simplify this view a little bit. Okay, so this looks a lot like Event Viewer, right? So imagine doing this script on a bunch of machines, getting all of the log data, dumping it into a table like this. It can go up to 1 million records. And then even within this UI, there is a simple query model where you can actually go and do queries over that data. So for example, I can go and do a filter and say entry type equals error. And I only get the error records. Okay, so very simple database, very simple to insert the data in there. You don't really have to think about the schema. If you want to change the properties that you're entering, you can just change the script, run it again, it gets inserted. You don't have to go think about how you change your database, how you adjust your schema, and so on. Okay, so just a little bit. I know we are a little bit behind time, so I'm going to give you just a quick look at how this thing actually looks in the background. So what happens is all the data, all this user table is stored in a series of databases. They're stored on the SOFS file system, on the SOFS scale-out file system at the bottom. And then we have a set of compute nodes. Those are those blue nodes. And on those compute nodes, there are a couple of roles. So there's a few processes running on each of those compute nodes. The most important process is these table server processes. They're responsible for managing and updating all the data. So each one of those, think of them as query processors. It's a transaction and query processors. Each one of those owns so each database belongs at any point of time to one of those table servers. And they can switch. We're doing automatic load balancing between them when we notice some additional load. The table master just helps the table servers coordinate. So the table master helps the table servers coordinate so we know that at any point of time one database belongs to exactly one table server. On top of that is just a bunch of front ends that take requests from the applications and do some basic load balancing. And then on top of that is the software load balancing. And one of those requests that we showed that the application was doing earlier is going like this. So the application issues the request. This is an HTTP request. So there's some body in there that's either XML or JSON. That gets load balanced into one of the front ends. The job of the front end is to simply parse that and then decide, look at the request, figure out which table needs to be updated or queried. It goes and finds the right table server. The table server takes the request and it does the actual processing. So if it's transaction, it will go and update the table. If it's a query, it will go fetch the data from the table. It will do all the filtering and so on. Compose the result. Compose the result, send it back to the front end. The front end will format that into some nice JSON and send it back to the application. That's basically how the system works. Now, we ran out of time. Otherwise, I can tell you guys more about how these table servers work in the background, how they load balance, high availability, and so on and so on. But we'll deal with that in the next time we talk about this. Do we have time for questions?
Yeah, that's fine. You could just go to the last summary slide.
Okay. So just as a summary, what you're getting here is consistent blob, table, and account management services. This is part of the software-defined storage that Microsoft is offering you at several of these levels. And it's really the storage from Microsoft Azure Stack. So this is the storage part of the Microsoft Azure Stack, which you will be able to see this in preview this year. and we are targeting the 2016 wave alongside Windows Server 2016. You get a consistent set of tools and APIs. So there's already an ecosystem formed around Azure, around tooling and API, both from Microsoft and third parties. There are tools like Storage Explorer from third parties, and you will get that to work with your deployments in your private clouds or hosted clouds.
Yep, that's fine.
And a couple of other things, if you're interested in this, there's an alias there where you can contact us and we can get in some deeper discussions. We are planning a private preview also fairly soon, within the next few months. And we'd like to take your feedback. And that's all we have.
Yep. Yep.
Thank you.
Yeah. Apologies, folks. It ran a little longer than we anticipated, but we will stick around for as long as you guys want. We can have a discussion offline. Thank you very much.